Good day, guys. Darian Giuseppe here again, back with another video for the Key Concepts series. What we're going to look at today, we're still on algebra of complex numbers. Remember, in my previous video, we looked at algebra of complex numbers. We looked at the addition, subtraction, and multiplication of complex numbers. But we also need to look at the division of two complex numbers. That is very key as well. So we're going to look at that today. But before we get into the division of complex numbers, we need to understand what is the conjugate of a complex number. So with that said, let's get straight into this video. So the little heading here is the conjugate of a complex number. And probably asking, what is the conjugate of a complex number? Let's consider a complex number. Z is equal to x plus iy, where x and y are just, variables that we use in. They could be any real number. So consider the complex number this here. The conjugate of this complex number here is simply a change in sign between the real and imaginary part. That is it. That's what you need to remember and understand. It's a change in sign here. So if your sign was positive as it is here, the conjugate for this will just be x minus iy. But how we'd like to denote the conjugate of the complex number is by z bar. So we just put a bar on top of it here. Sometimes they denote it by z star as well. They put a little star right in the corner there. So that's basically it, right? You have a complex number. Its conjugate is simply a change in sign between the real and imaginary part. That's basically it. So this is what we have here. The conjugate is given by z bar, which is equal to x minus iy. So this is your change here. Big change there. And you see we represented by z bar. Some places you see it's denoted as well by z star. So that is the conjugate of a complex number. With the conjugate of a complex number, we notice a few results, right? The first result we notice, and we just want to note these things, right? The first result we notice is that when you take the complex number, let's say we take z is equal to x plus iy, and we add it to z is equal to x minus iy, which is its conjugate, we get, and you can see it, the imaginary parts will cancel off, and you'll be left with 2 by x. And in general, what we see is that the complex number plus its conjugate is 2 times the real part of z. So that's basically it in general. So that's the first little result we notice about the complex number and its conjugate. The next result we notice about the complex number and its conjugate is if you take the complex number and you minus it from its conjugate, what you will get is this here. This is the general result. You will get 2 by the imaginary part of z by I. Don't forget the I. Right? So that is our next little result we notice about the complex number and its conjugate. And then the last result, which is to me the most important result about the complex number and its conjugate, because we're going to use this result in the division of complex numbers, is that if we take the complex number, z is equal to x plus iy, and multiply it by its conjugate, z bar is equal to x minus iy, what we will notice, we will get the real part squared, which is x squared, plus the imaginary part squared, which is y squared. That is the result we notice occurring. So this is the next result. This is very important, right? And what you would notice as well, because you know the result, you don't necessarily have to take this and multiply it by this using distributive rule that we looked at previously. If you know that this is a complex number and its conjugate, you could just simply write down the real part squared plus the imaginary part squared, because you know that result is true. So that is that. Let's get into the meat of the matter in terms of this video, which is looking at the division of two complex numbers. So that is what we have here. So let's just consider the complex number z is equal to, and we're going to put two complex numbers one on top of the other, right? Z is equal to 4 plus I on negative 3 minus 5i. So how do we go about this dividing these two complex numbers? Or you might look at this and we could say, well, when we look at these two complex numbers being divided, we should, you might expect, well, yeah, you should get back another complex number of this form, um, x plus iy. You should expect that. But we cannot see, you can't see clearly what is the real part or what is the imaginary part. Can't see it. It's real difficult to see. So what we do, we use this process called realization. We realize the denominator, or we make the denominator real. We make it a real number. And that's a process whereby or we use to divide two complex numbers. So what we would do is we would multiply the denominator, and that's where this rule will come into play. This result will come into play, where the complex number and its conjugate is concerned, the multiplication of it, the complex number and its conjugate. So what we do is we multiply the denominator by its conjugate, and we multiply the numerator by the conjugate of the denominator. So that's what we need to do. So what we will have is this. So you could see clearly the conjugate of this is this here, because look at the change in sign there. And we basically multiply by the conjugate of the denominator in the denominator and in the numerator. And this whole thing here is the same as this, right? You can see it clearly because this by this is 1, and 1 by anything is itself. So nothing really has changed there in terms of what it is. It's basically the same thing. We just manipulating it to try to get it into a different form. That's the key. And what we do next is we multiply your numerator by a numerator here and a denominator here by this. But you will see clearly this is what you would get in the numerator and denominator. The numerator, you will have to use the distributive rule of multiplication of the two complex numbers that we looked at in the previous video. For the numerator, you will have to do that. But the denominator, to save time, the denominator is a complex number by its conjugate. So all you need to do is recall this result, the real part squared plus the imaginary part squared. So I will just square -3 and square either -5 or +5. It doesn't matter which one you square because you will get +25. So this is what we have in the denominator here. And then don't forget your -I squared will turn to -1. And you just work out, you would bring your real with your real in the numerator and your imaginary with the imaginary and work them out. So this is what we will get here. And then you could clearly see things starting to work out for you. You could take this and divide it by the real part here and divide it by the imaginary part. And what we have here in the end, or close to the end, that is -17 and 34 plus 17 and 34i. And we could reduce this, you can see, because 34 can, or 17 could go into 34 2 times. So in the end, this is what we get. We can clearly see now the real part of this complex number. You can clearly see the imaginary part of the complex number. So the real part is -1/2 and the imaginary part is +1/2. So this here is another way of rewriting this, where you can clearly see now the real and imaginary part. So that is that. That is the division of a complex number, or of two complex numbers, the conjugate of a complex number. Guys, I hope this video helped. Don't forget to like and subscribe to the channel. Feel free to share it to someone that you feel it will be helpful to. And with that said, thanks for watching the video and see you in the next video.